Privet, and welcome to the first part of our Unit 5 presentation on Advanced Data Modeling for CIS 3107, Database Modeling. We'll be covering Section 5.1 in our text. In this first presentation, we will learn about the Extended Entity Relationship, EER model. As the complexity of the data structures being modeled has increased, and as application software requirements have become more stringent, the need to capture more information in the data model has increased. The Extended Entity Relationship Model, the EERM, sometimes referred to as the Enhanced Entity Relationship Model, is the result of adding more semantic constructs to the original entity relationship, ER model. As you might expect, a diagram that uses the EERM is called an EER diagram, EERD. Entity supertype is a generic entity type related to one or more entity subtypes and contains common characteristics. The entity subtype contains unique characteristics of each entity subtype. The criteria to determine the usage is that there must be different identifiable kinds of the entity in the user's environment, and the different kinds of instances should each have one or more attributes which are unique to that kind of instance. Entity supertypes and subtypes are organized in a specialization hierarchy, which depicts the arrangement of high-level entity supertypes, parent entities, and lower-level entity subtypes, child entities. The relationships depicted within the specialization hierarchy are sometimes described in terms of a, quote, is a, end quote, relationship. It is important to understand that within a specialization hierarchy, a subtype can exist only within the context of a supertype, and every subtype can have only one supertype to which it is directly related. However, a specialization hierarchy can have many levels of supertype-subtype relationships. That is, you can have a specialization hierarchy in which a supertype has many subtypes. In turn, one of the subtypes is the supertype to the other lower-level subtypes. Specialization hierarchies enable the data model to capture additional semantic content or meaning into the ERD. A specialization hierarchy provides the means to support attribute inheritance, define a special supertype attribute known as the subtype discriminator, and define the disjoint/overlapping constraints and complete/partial constraints. The following sections cover such characteristics and constraints in more detail. Figure 5.2 shows the specialization hierarchy formed by an employee supertype and three entity subtypes, pilot, mechanic, and accountant. The specialization hierarchy reflects the one-to-one relationship between employee and its subtypes. For example, a pilot subtype occurrence is related to one instance of the employee supertype, and a mechanic subtype occurrence is related to one instance of the employee supertype. Quote, is a, end quote, relationship examples in this figure are a pilot is an employee, a mechanic is an employee, and an accountant is an employee. Note the arrangement of the entity supertypes and subtypes in the specialization hierarchy is more than a cosmetic convenience. They enable the data model to capture additional semantic meaning into the ERD. The property of inheritance enables an entity subtype to inherit the attributes and relationships of the supertype. As discussed earlier, a supertype contains attributes that are common to all of its subtypes. In contrast, subtypes contain only the attributes that are unique to the subtype. One important inheritance characteristic is that all entity subtypes inherit their primary key attribute from their supertype. At the implementation level, the supertype and its subtypes depicted in the specialization hierarchy maintain a one-to-one relationship. Figure 5.2 further illustrates inheritance as the pilots, mechanics, and accountants all inherit the employee number, last name, first name, middle initial, and hire date from the employee entity. Yet, the subtype pilot has unique attributes. The same is true for mechanic and accountant subtypes. Note that the EMP_NUM attribute is the primary key for each of the subtypes. A subtype discriminator is the attribute in the supertype entity that determines to which subtype the supertype occurrence is related. As we saw in the previous figure 5.2, the subtype discriminator is the employee type, EMP_TYPE. Note that the default comparison condition for the subtype discriminator attribute is the equality comparison. However, in some situations, the subtype discriminator is not necessarily based on a quality comparison. An entity supertype can have disjoint or overlapping entity subtypes. Disjoint subtypes, also known as non-overlapping subtypes, are subtypes that contain a unique subset of the supertype entity. In other words, each entity instance of the supertype can appear in only one of the subtypes. This subtype is implemented based on the value of the subtype discriminator attribute in the supertype. On the other hand, if the business rule specifies that employees can have multiple classifications, the employee supertype may contain overlapping job classification subtypes. Overlapping subtypes are subtypes that contain non-unique subsets of the supertype entity set. That is, each entity instance of the supertype may appear in more than one subtype. The overlapping subtype implementation requires the use of one discriminator attribute for each subtype. In our aviation example, an employee can be a pilot, a mechanic, or an accountant. If we assume that one of the business rules dictates that an employee cannot belong to more than one subtype at a time, that is, an employee cannot be a pilot and a mechanic at the same time, then employee supertype, who is a pilot subtype, can appear only in the pilot subtype, not in any of the other subtypes. In an ERD, such disjoint subtypes are indicated by the letter D inside the category shape. Figure 5.4 illustrates overlapping subtypes with a letter O inside the category shape. An employee may be a professor as well as an administrator. Because an employee may also be a student, student and employee are overlapping subtypes of the supertype person, just as professor and administrator are overlapping subtypes of the supertype employee. It is common practice to show disjoint and overlapping symbols in the ERD. As we learned earlier in this presentation, the implementation of disjoint subtypes is based on the value of the subtype discriminator attribute in the supertype. However, implementing overlapping subtypes requires the use of one discriminator attribute for each subtype. For example, a professor can also be an administrator. Therefore, the employee supertype would have the subtype discriminator attributes and values shown in Table 5.1. The completeness constraint specifies whether each entity supertype occurrence must also be a member of at least one subtype. The completeness constraint can be a partial or total. Partial completeness means that not every supertype occurrence is a member of a subtype. Some supertype occurrences may not be members of any subtype. Total completeness means that every supertype occurrence must be a member of at least one subtype. The ERDs in figures 5.2 and 5.4 represent the completeness as a single horizontal line under the circle represents a partial completeness constraint. A double horizontal line under the circle represents a total completeness constraint. Given the disjoint and overlapping subtypes and completeness constraints, it is possible to have the specialization hierarchy constraints scenarios summarized and shown in Table 5.2. Specialization is the top-down process of identifying lower-level, more specific entity subtypes from a higher-level entity supertype. Specialization is based on grouping the unique characteristics and relationships of the subtypes. In the aviation example, you use specialization to identify multiple entity subtypes from their original employee supertype. Generalization is the bottom-up process of identifying a higher-level, more generic entity supertype from lower-level entity subtypes. Generalization is based on grouping the common characteristics and relationships of the subtypes. In summary, the extended entity relationship, the EER model, adds semantics to the ER model via entity supertypes, subtypes, and clusters. An entity supertype is a generic entity type that is related to one or more entity subtypes. A specialization hierarchy depicts the arrangement and relationships between the entity supertypes and the entity subtypes. Furthermore, inheritance means that an entity subtype inherits the attributes and relationships of the supertype. Subtypes can be either disjoint or overlapping. The subtype discriminator is used to determine to which entity subtype the supertype occurrence is related. These subtypes can exhibit partial or total completeness. There are basically two approaches to developing a specialization hierarchy of entity supertypes and subtypes: specialization and generalization. Thank you for watching our Unit 5 Part 1 presentation. The diagrams and content of this lecture were derived from our textbook. For a more detailed treatment of these concepts, please review pages 169 to 176 in our text.